Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're looking at our third section in Chapter 3. We're continuing our quadratic equations discussion. The last video we looked at how to solve using the quadratic formula. So this lesson is about some applied problems. If I give you a word problem, such as a rectangle with the area of 270 square feet. This one's saying find the dimensions, being the length and the width. So we've got a length here and the width, and we know that length times width will equal 270 because that's how to find area. But we are not given the length and the width. So let's continue reading here after I can get a proper L here. It's given that the width is 3 feet less than the length. So I'm just going to literally use this word is as an equal. The width is 3 feet less than the length. Now be careful, that's not 3 minus, even though they mention the word 3. If I go 3 less than your age, you would start with your age and subtract 3. So when you go 3 feet less than something, you need to start with that something and decrease it by 3. All right, so now we have a nice equation all in terms of L's because we're replacing W with the value. W is now L minus 3, so I'll replace this W with L minus 3 and set it equal to 270. And then I think I'm home free. I'll distribute. So I'll get L squared minus 3L equals 270. I'll try to set it equal to 0. And we could either use the quadratic formula here, or you could hunt for factors of 270, whichever one you feel more comfortable with. It turns out that 18 and 15 are factors of 270. Again, some students find this really daunting to be looking for these factors. I think it's easier to look for these factors than it is to do the quadratic formula. Signs are going to be different. The larger term is negative, so L minus 18 and L plus 15. But when you solve for this L, you get a negative 15, which really doesn't make sense for a length of a rectangle. So I'm going to go with L equals 18. And if L does equal 18, then 18 minus 3 will be the width, and the width turns out to be 15, and that's just a coincidence that this was negative 15. So I think the author here sets it up the same way, but chooses to solve it using the quadratic formula instead of factoring. But notice that I think that's a longer process. They still get the same answer. They still throw out the negative 15, and they still get 18 feet for the length, and again, solving for the width is 15 feet. Let's try another one. The hypotenuse of a right triangle, I like drawing a picture that doesn't even look like a right triangle, is 52 yards. One leg is 28 longer than the other. So if I let this be one leg, and then the other leg is 28 yards longer, everything's in terms of yards, so I don't have to do any conversions, then I remember my a squared plus b squared equaling c squared from my geometry days. So L squared plus L plus 28 squared are the two legs, and that should equal 52 squared. Numbers get a little bit large here. I'm going to square the first, twice the product, so twice 28 is 56, and then I'm going to square the last, 784, and 52 squared is 2704. I'm going to set this, I'm going to combine like terms first, so 2L squared plus 56L, and can I subtract off the 2704 from both sides as well? And the goal there would be to set it equal to 0. So this turns out to be negative 960. It looks like everything divides nicely by 2, so I'm going to go ahead and do that. It just makes the numbers a little bit smaller, so I don't have to hunt for quite so many factors. I would always suggest looking for that. I think this number here should have been my 1920. And then when I divide 2, I'll get the 960. So I'm looking for factors of 960 that differ by 28. And again, I would hunt around on the calculator and look for those. You know there are going to be two fairly large numbers. Turns out to be 48 and 20. Signs are different. The larger term is positive, x plus and L minus, but L equaling negative 48 once again does not make any sense. So I'll go with L equals 20, and 20 plus 28 will be the other. And again, it's just a coincidence that that's a negative 48. So the two lengths are 20 and 48. Again, the author chose to do the quadratic formula. The numbers get quite large. And then you have to simplify the square root, which turns out to be quite nice, actually. But again, they get the same results. We throw out the negative 48. That doesn't make sense. 20 yards is left, and evaluate and get negative 48 for the other one. So we've got another 48. He traveled. So whenever I start talking about distance, rate, and time, I usually like to write down distance equals rate times time. And it looks like he's going to travel 48 miles for both scenarios. So this is actually what he did. And then they say, hey, if he would have gone the same distance and gone 4 miles, so we don't know what the rate was the first time he traveled, but if he would have gone 4 miles an hour faster, so if he would have increased his rate by 4, he could have decreased his time, which we also don't know is time, by 1 hour less. So I'm going to set my distances equal to each other. So let's see. If distance equals rate times time, then your rate, if I divide through by time, the rate will equal distance divided by time. You don't have to do that method. I mean, I suppose we could just set the first equation, 48 is equal to rate times time. The second equation is 48 is equal to the rate, which is r plus 4 times its time. But I was just trying to avoid, this is going to be a little bit of a mess. You can try the green method by solving by systems, but I really think this method over here, this purple method, is going to be a little bit easier. So let's play around with this. Solving for this rate, I'll take the rate and take the distance, which is 48, and divide by time. So that's one equation. And then the other equation would be its distance, which again is 48. No, the rate, which is r plus 4, should equal its distance, which is 48, divided by its time, t minus 1. I think this is a little bit easier because I see some substitution going here. If rate is 48 divided by time, I can replace these rates. So I'm going to substitute that rate in here. So I'll have 48 over t for my new rate plus 4 should equal 48 over t minus 1. It's a mess. It doesn't matter whether you do the green method or you do the red method. Either way is going to be difficult. I'm going to multiply through by a common denominator. And it looks like the common denominator is t and t minus 1. I have to choose every factor as many times as it appears in each denominator. So I'm going to multiply through by t and t minus 1. And I'm going to do that to every term. So it looks like I've multiplied the left side twice and the right side only once. But I didn't. I just multiplied both sides by the common denominator, this pink. And then I distributed the pink to every term on the left. So again, it looks like there's two pinks on the left and one pink on the right, but I just distributed the pink to every term. And the reason why I did that distributing is because it's easier for me to see what's left. So these t's are going to cancel here. Unfortunately, nothing cancels there. And these t minus 1s are going to cancel. So what I have left is, I'm going to distribute this 48. 48t minus 48 This is a 4t that I have to distribute. So 4t times, I'll just write it, plus 4t times t minus 1. I'll distribute in the next step. And then over here, these cancel, but I'm left with this 48t. Difficult problem. I hope you're following here. I'm going to distribute this 4t as promised. So 4t squared minus 4t. I'm going to combine some like terms. Actually, if I subtract off 48t from both sides, looks like I can set it equal to 0, so forget about combining like terms. The only thing I have left is, I'll reorganize this thing. It's 4t squared minus 4t, which is this term, minus the 48. Oh, and it looks like I can divide through by 4. That, again, makes the numbers a little bit smaller for me. And then either I could do the quadratic formula or try to factor. Factors of 12 that differ by 1 are 4 and 3. So signs are different. The larger term is negative, so I'll stick the negative with the 4. And time being negative 3 doesn't make sense, so I'll stick with time equals 4. Here's how the author, they went ahead and they solved for these rates and did a little substitution. Again, that's, I think, the easiest way to do that. You can pause the video here if you'd like and see, but they get the same answers. T is 4. I bet they threw out the negative 3 on the next one. Good. Disregard the negative 3. Oh, we forgot to answer the question. Shoot. The original question said, find Cade's speed. Well, we ended up with time. So his time is 4, what is it, minutes, 4 hours. So we're actually going to plug that 4 back into this formula here, which says r is equal to 48 divided by the time. And we know that the time now is 4. And so his rate is going to be 48 divided by 4. And that's how the author is, there it is, 48 divided by 4. That's how the author is going to get 12 miles per hour. So we need to make sure that we're actually answering the correct question. We can't just solve for a variable. So 12 miles per hour is Cade's speed. Here's steps that I've written down to help solve for equations. I usually try to distribute by simplifying or combining like terms, get all the variables on the same side, add or subtract, multiply, and divide. But we're going to do it not with numbers, but we're going to do this with letters, which is a difficult concept for students. So again, I'm going to solve for a, so I get all the variables on the same side. There's nothing to distribute or simplify or combine, and all the a's are right on the same time. So I'm ready to add or subtract. So a squared is equal to, and I'm going to throw both of those terms on the other side. So d squared minus the b squared minus the c squared, and then I just take the square root of both sides. Remember though, when you take the square root, we get 2 answers. This doesn't look pretty, but I think that's all I can do to solve for a. It looks like the author agrees. And the last example, well, to solve for n, I would undo what's happening to n. And right now, n, there's a 1/2. So let's double both sides. I can do whatever I want to both sides of the equation. So I guess the first thing I'll do is get rid of the 2. This is a hard problem. To solve for n, I'm going to try to set it equal to 0 and factor. But there's no way to find... there's no way to find factors of 2d that differ by 5, so I guess I'm left with actually doing the quadratic formula. But instead of x is equal to, let's do n is equal to. N is equal to negative, well, let's see, the value of a is 1, b is negative 5, and c is a constant, which remember, it's not 2, it's this whole term, 2d. It's just like a number. It's like 2 pi. Very hard problem. So the opposite of b is the opposite of negative 5, which is 5, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the a term. So simplifying this, let's see, this is, I can't do much. 25 minus 8d. Wow, I just really don't know what to do after that. Might be done. This looks like a trap to me, like they want you to simplify the square root of 25, but I know that the square root of x squared plus y squared does not equal x plus y. That's a trap that a lot of students head into, so we can't, I know what they're thinking. If it was multiplication, then fine, I could break that up to be xy, but this minus sign means I can't do anything. I think I'm done. Good, the author agrees. That was just a bizarre problem. I hope you don't have many of those on your homework. If you do, shoot me an email and I'll try to help you through them. Good luck.